So we've talked about half duplex and full duplex earlier, but maybe now it might make more sense. So remember that half duplex is sort of like a two-way radio. You can talk if you press a button, and then you let go of the button and you can listen. So the idea is that you cannot talk and listen at the same time. You can only do one or the other. And Ethernet on hubs work that way. They work only in half duplex because of the way hubs work. Or if you have the old style logical buses, it was the same thing. Full duplex, on the other hand, is what we have now. That means the switch or the NIC can transmit and receive simultaneously. It's more like a telephone where you can talk and listen at the same time. And so in this mode, CSMA CD is turned off, even though it's still there, just in case someone has a hub on your network. It's still there, but most of the time we don't use it because we don't need it. We have a logical switch connection in a star topology, and so that allows us to have everything operate in full duplex, and most switches do that. Most switches operate in full duplex. So full duplex is what we use. If you do have a hub in your LAN, then one part of your network will go to half duplex mode. And so sharing the bandwidth. Okay, so let's take a look at some Ethernet standards. This is how you'll see it described in most of the places. So it's usually described as X base Y. X is a number, which is the speed of transmission. So for example, you say 10 base 2 or 10 base T is more common, and these days you're more likely to see 100 base T, and if you have fiber optic you might see 100 base F or FX. So X, that's the number, is the speed of transmission in megabits per second. The Y is the type of media. You see 2 for coaxial, T for twisted pair, and FX for fiber optic. Remember the base, we talked about it just a short time ago, is baseband transmission, which means you're sending ones and zeros as sort of low and high voltages. So base is baseband transmission. So for example, 10 base T means that you're using 10 megabit per second speed, baseband transmission, that is ones and zeros as low and high signals, and then T for twisted pair. This is an old protocol. It's slower than what we use these days, and it ran over even Cat3 cables. You can use Cat5, but it's sort of overkill. So 10 base T is older. Just like with the 100 base T, just use 2 of the 4 pairs. It can run over Cat5, but Cat3 is enough. And it is old, and it is susceptible to collisions. It was used when we had hubs and things, and it's pretty much obsolete. It's unlikely that you will see it in most environments. So once again, 10 base T, the number is the speed, 10 megabits per second. Base stands for baseband electrical signaling, and T is twisted pair. Uses 2 of the 4 pairs of wires, just like signals that we use these days, and can work on Cat3. Okay, 100 base TX, 100 stands for 100 megabits per second. Base is baseband as usual, and TX is twisted pair, and it uses Cat5 or higher cabling, which is what we use in the lab. Uses 2 of the 4 pairs, and this is the most common Ethernet variety. You could use hubs in these days, but of course then you introduce a collision domain and it's not so good. So most of the time, if you want speed, you use switches. So the TX part is was used because there was a T4 standard, 100 base T4 standard, which used all four pairs, um, and that was using Cat3 cables. These days we don't use this at all. 100 base T4. We use 100 base TX, which means that you're only using two of the four pairs. You might also see 100 base FX. 100 is the speed, 100 megabits per second as before. Base is baseband, and FX stands for fiber optic cables. You can have Ethernet over fiber optic cables. Of course, you need special circuitry that will send light instead of electrical signals. So you can do that. And this is used for main or backbone or trunk line cabling between switches and routers, things like that. Because it's expensive to have those optical circuitry, you don't find it all that much, and these days electrical or copper cabling has pretty much caught up. People are able to produce fast circuits using fast networks using copper. 1000 base T, once again, this is the speed in megabits per second, so 1000 megabits per second is the same as 1 gigabit per second, and this works on twisted pair copper. Cat5e can usually handle 1000 base T, but most of the time we use Cat6 for 1 gigabit per second. So Cat5 or higher, but Cat6 is probably better. Unshielded twisted pair. And so this 1000 base T Ethernet standard uses all four wire pairs. And lastly, we'll just take a quick look at the Wi-Fi standard. So this is 802.11. I'm just going to scroll back up, and maybe I didn't mention it, but Ethernet is 802.3. Hopefully it was in one of the earlier slides. So 802.3 is the Ethernet standard, and 802.11 or 802.11 is the Wi-Fi standard. So all of the stuff that we use in the lab, that's all 802.3. If you see 802.11, you know that's Wi-Fi. That's a wireless network. It was just marketing. They called it wireless fidelity, sort of like hi-fi or high fidelity, and then it was called Wi-Fi, and that's how most people refer to it. It's used for convenience. You no longer have to have cabling, no wires, so you don't have to worry about that. But then you have to worry about making sure that no one's snooping on the traffic, because it's just going through the air. 802.11 is essentially just an extension to Ethernet, and it uses airwaves instead of cabling as the media. And so to have the same level of privacy using airwaves, you have to use something, and that's something that makes it so that everything is private is encryption. You use encryption to provide the same level of privacy as cables. That's the idea.